Hello guys, welcome to another brand new section. In this section, we are going to be building the React agent using LangGraph. Okay, so in the previous section, we learned everything there is to know about state in LangGraph, how to use custom state. So we are going to be employing all of that to build out our React agent. So I know that we did, implement the React agent using LangChain's, out of the box classes like initialize agent method and agent executor classes. But in this, section, we are going to eliminate, the agent executor, and we are going to have full control over the looping that happens between the LLM and LangChain, between LLM and LangChain. We are going to have full control because this time we are going to be using our graph data structure. We are going to be using LangGraph. So before we proceed forward, let's quickly jog your memory about, what is the React agent, what pattern does it follow. So if you remember this particular slide, so you can see that, the LLM first thinks, let's say you're giving the LLM a problem to solve. It first thinks about the user's prompt or the problem, and then we have action. The LLM decides if it can answer by itself or if it should use a tool. So once it decides, once it makes that decision, it is then, if it decides that it is going to use a tool, the action input is going to be the LLM provides the input arguments for the tool, right? So once the input argument is provided, LangChain's, out of the box class, it just like stops, the streaming of the LLM. It tells the LLM shut up. It just basically takes the think action input. It is then going to call the tool, execute the tool, get the response, and with all the entire history, it is again going to send it back to the LLM. And now the LLM is going to observe the result of the tool. And if the entire problem is solved at that particular point, this is the final answer, or else the same loop is going to continue. So the problem that we faced was that we did not really have control over that default class that LangChain provided for running the React agent, right? Because sometimes we went into the infinite loop problem. We do not have the control to ourselves, right? So that is exactly what we are going to be solving using LangGraph. Okay, so before we actually start implementing LangGraph, let's actually take a quick peek into this method. Okay, so let me actually come back to the first introduction where we built out the React agent. So here you can see that we've used the initialize agent method. Okay, so let's actually take a quick peek into what is exactly happening. What are the components that sort of come together to build out the React agent? Okay, so that is what I've written here. So in LangChain, we use the initialize agent as an all-in-one solution, right? So that is exactly what we've used right here. It basically just takes in the tool, the LLM, the prompt as well, the React prompt. We're telling the method use the React prompt. Inside of it, the React prompt would have been written, and then we are setting the verbose to true as well, right? So this is what we're using as an all-in-one solution. But it combines two key components. So the first one is going to be the create a React agent method. Okay, just on a very high level, think that this is a method that does one thing, and then along with that, we also have the agent executor class. Okay, so this is exactly what we are going to eliminate for LangGraph. Okay, so this is what actually controls the looping between LangChain and LLM. Between LangChain and LLM, this looping is being done by agent executor, and that is exactly what we are going to be replacing using LangGraph. All right, so create React agent. So what is it? So you can basically think of this method to be that method that creates the agent. Obviously, everything's got to come together to create the agent, including the looping. But for now, just think that this is what is going to create the agent. So what does it do? It just takes each tool's name and description. Okay, so you can imagine that we would have provided a few tools to solve that problem, right? So let's come back to the code. We see that we have the search tool right here. We have the get system tool right here. And this entire tools is provided to this particular method, right? So let's see what it does. So it basically takes each tool's name and description. Okay, so we have the name right here and we have the description right here. Okay, all these things are not going to be taken at all. These things are not going to be considered at all. Just these two things are going to be taken. And then it formats them into a standardized way the LLM can understand. Okay, so basically it's going to convert it into a string, and then it inserts them into specific placeholders in the React prompt template. Okay, so let's quickly look at the React prompt template. So here you can see that we have a placeholder for tools and then we have a placeholder for tool names, right? So that is exactly what this method is going to do. It is basically just going to take the name and description of various tools. It's going to structure it, it's going to parse it, it's going to make it into a proper string, and then it is going to combine it with the prompt React prompt template, so that when we send it to the LLM is going to have full context about what are the tools that it can work with. All right. So not just that, okay, it doesn't just do the merging, it also makes the LLM call, and okay, it makes the LLM call. So the LLM is now going to proceed forward with generating, what is this? It is going to start generating the question, thought, action input. Okay, so these four things it is going to start generating, and the minute the action input is received and the minute we actually start going to this observation, okay, so the minute this is coming to an end, the streaming that happens between this particular method, the streaming that happens between this particular method and the LLM, that is interrupted. Okay, so we don't really want what happens after that. Okay, we don't want the LLM to continue, because the LLM is not going to have the result of the tool, right? So what I mean by this is, up until this point, okay, up until this point, the LLM needs to generate the action input. As soon as the action input is received, the LLM is going to stop it. Okay, this particular method is going to tell LLM to stop streaming. Okay, your work is done. I now have the action input. It's going to get that action input. Okay, so that is what it does. It makes the LLM call. It takes the LLM's response, and then it parses it. Okay, so this is an example, let's say. Okay, so first off, the LLM is like, thought, action input. The thought could be, I need to find out when SpaceX's last launch was and calculate the days since. Okay, so if you remember that this was the first prompt, the problem that we provided to the LLM, right? So it is first thinking to itself, and then the LLM is deciding I want to use the search tool, and then it is also providing the input to the Tavily search tool. Okay, so let's say this is up until this point, this method is going to allow the LLM to generate, and as soon as this is done and the observation is started, cut, and then the data is going to come back to this particular method. And finally, once it has these three things right here, it is going to parse the response of the LLM into one of these two classes. Okay, so this method is just going to return two things. It is either going to return the agent action class or the agent finish class. So let's actually look at what this agent action and agent finish looks like. So this is a LangChain class that represents an action the agent wants to take. It typically contains something like this. So this is how the complete, parsed output is going to look like. It's going to be an agent action class. It is going to have the tool input and log. The tool is going to be what tool to use, the input to the tool, and then why the LLM thinks that it needs to use this tool. So this three data is essentially what these three things are going to contain. The thought is the reasoning, and that is exactly what is going to be put in the log. And the action is going to be which tool to take. That is exactly what is going to be converted into this tool input. And then finally we have the action input, and that is going to be this tool input. Okay, so it just like parses it and creates this particular class, agent action class. Okay, I really hope that makes sense. So in case that the LLM is actually does not need to call another tool, it thinks that I don't really need to call a tool, my answer is done, my work is done, I have all the information that I need, I have the final answer. In that case, this particular method, the create react agent method, is going to return the agent finish class. So this represents the agent completing its task with a final answer. It typically contains, this is going to be the output, and this is the log as well. Okay, so now I really hope that you understand what the first key component of React agent does. So this is going to be 50% of the work that is done by this initialize agent method. Okay, so let's look at the second key component of this initialize agent method, and that is going to be the agent executor. So let's see what it does. It takes the agent from create react agent, okay, and then manages the execution loop. So you can imagine that the create react agent method is going to output parse the agent action and the agent finish. but something's got to control the looping between the LangChain class as well as the LLM, right? So after the LLM is done, the control needs to come back to the LangChain. LangChain's got to parse it. It's going to call the tool, and as soon as the tool is called, again all of the data needs to be sent back to the LLM along with the history. So all of that looping is being done by the agent executor. I hope that makes sense. So it basically takes the agent that is created from the create React agent method and manages the execution loop. It receives the user's question and feeds it to the agent. Okay. And then it identifies which tool to run based on the agent's output. Agent action, or if it is no tool required, then agent finish. So it executes the tool and captures the result, feeds the result back to the agent for the next decision. It continues this loop until the agent produces an agent finish class, returns the final answer then to the user. Okay, so to put it very short, agent executor is what is actually going to be controlling the looping between the R system as well as the LLM. So this is where we actually lost control a little bit because of the infinite looping problem. So if I actually go back and go inside of the initialize agent, you can see that it is actually returning the agent executor. Okay, so this is why this is not really in our control at all. Okay, so if we mess up with the prompt, or we mess up, if we don't provide a tool or anything, then it's going to malfunction, and we don't really want that. So this is exactly where there is a drawback, and this is what we are going to replace, or rather eliminate, using LangGraph. So we are going to gain control of the looping. So let's actually look at some of the key advantages of using LangGraph. So LangGraph basically turns the hidden black box loop into a visible, editable workflow. So you can now add custom nodes, modify the flow, insert additional logic. So this is going to be the LangGraph graph for the React agent. And then we have the reason node and the acting node. So together is what is React, right? Reasoning plus acting. So let's actually look at what this graph means. So the reason node does what create React agent did. It thinks and decides. If the reason node outputs an agent action, then act node executes the tool. The results from the tool flow back to reason node for the next decision. When the agent has the final answer, it takes the right path to end. This visualization makes the black box of agent executor transparent and modifiable. So I really hope that this introduction makes sense. If it does not, don't worry. We are going to be, dissecting it, and we are going to be looking at it in much more depth. But yeah, in the next section, we are going to be looking at how we can build out the reason node right here. So I'll see you in the next section.